All right, find the arc length. So this was one of the topics that you've been doing on your own, whether you did it before spring break or whether you've done it this week. So I'd remind you, if you haven't done topic 5 and topic 6 on the Delta Math assignments, to get on there. There's great videos. We'll take you right through it. Essentially, arc length is us wanting to find a percentage of the distance around the circle. All right, so now we've kind of switched into a distance idea as opposed to a measure. All right, so we know that the entire measure around the circle is 360. So if I want to know just this part, then what I'm talking about here is that this is 75 degrees out of a possible 360. That's the percentage of the circle that I want to know the length of. Okay, so that's where this 75 divided by 360 comes from. And then we have that to multiply by 2 times pi times r, r being the radius. So in this case, 2 pi, and then the radius they told us was 10. All right, so this is everything that I've got right here. This is really the percentage of the circle that I'm talking about, that highlighted piece. And then 2 pi r, this is the entire distance around the circle. It's called the circumference. That circumference formula is 2 pi r. All right, so then all we've got to do is just plug that into our calculator. All right, so once we've got that typed into the calculator, what I ended up with, and I just typed it in exactly how I had it, and I used the pi button on your TI Nspire. It's down there kind of in the bottom left. Click on it, it'll bring up another little menu. Just select the pi key or the pi symbol there. And what I ended up was 13.089. Okay, and if you notice, these are rounded to the nearest tenth. So the only option that it could be there is that 13.1. Remember, that was in kilometers. Okay, so good to know. All right, let's take a look over here. I'm just going to abbreviate arc length so I don't have to humiliate myself with the horrible writing that I'm putting forth right now. And then here is the highlighted portion that they're talking about. They want to know, ooh, that was pretty bad. They want to know, what is that distance? So I'm talking about 225 degrees out of a possible 360. So I'm not talking about the whole distance around the circle, which would be 360 degrees. That would represent the whole thing. That's not what I'm talking about. I'm just talking about 225 degrees out of the possible 360. So that gives me the percentage of the circumference. So then I'm looking at 2 times pi times the radius in this case, which is 8. All right, and then what we're going to do is just type all that into our calculator, and then let's see, once we've done that, let's see what we end up with. All right, so once we type that in the calculator and hit enter, I ended up looking at 31, looks like 0.416. Since the previous problem was round to the nearest tenth, let's go to the nearest tenth, so let's just call it 31.4, and then don't forget your units here. We're talking about centimeters, so 31.4 centimeters. All right, we're getting close to the end here. This is number 17. This was also a topic that we didn't cover together. So you were responsible for doing the Delta Math assignment that talked about centers of circles and the equation of circles and the radius of circles and those types of things. So as I'm looking at this equation right here, I kind of think of this a little bit as what we did with point slope form back first semester, which is I'm going to do the opposite of what I see here in terms of like a shift or the transformation happening. So that's going to be a 2, and then this value is going to give me my y value, and that's going to be negative 11. So the center of this circle would be located at 2, negative 11. And then this 16 is going to help me with my radius value. So if you think about it, It's really like taking the square root of 16, which is equal to 4. All right, so there's my center, and there's my radius. And if you think about it, the radius squared, 4 squared is 16, so that makes sense. All right, they're giving us a center this time. 4 would be my my x value. If you want to put a little x up there and then a little y above the 0, that's fine. So I'd have something like this, x minus 4. It's meaning that I'm shifting right 4. All right, and then it has that quantity squared plus, all right, y. And if you wanted to, you could put in there y plus, in this case it's a 0, so plus or minus wouldn't really make a difference there when we're talking about 0. That's squared as well. And then that's going to be equal to 12 squared, and 12 times 12 is 144. So here is my equation. All right, and if you're wondering once again where did that 144 come from, I'm going to do this down here because all I have to do then is just write it out once. I don't have to rewrite the whole equation. But 12 squared is equal to 144. So that is the value that takes that place right there. Looking at 19, let's just roll right into that. You know, here's my x value of the center. There's my y value of the center. So what I'm looking at is x minus, looks like x minus 2. And then that quantity is going to be squared plus, this is going to be y plus 6. And that's quantity squared. And then in this case, the square root of 65 squared is actually just going to be 65. So there is my equation of the circle based on the information that they gave me. If you think about it, the square root of 65, if you type this into your calculator, so the square root of 65, you type that in there and you square it, the calculator is just going to spit out to you 65. And the reason that it's just going to spit out a 65 is because squaring and taking these square roots are inverse operations of each other. One other little note to add in here, if you wanted to think on number 18 and just leave this, since it's a 0, as a y squared, that would be perfectly fine as well. I just wanted to mention that in case any of you had written it that way. All right, let's look at the next problem here, which is number 20. This is going to be the center of the circle. So if I think about it from where 0, 0 would be from the origin, I've moved 1, 2, 3, 4 to the right, and then gone down 1. So if I think about the center of this circle is at 4, negative 1. Having trouble with that bracket or that parenthesis there. And then the radius is 1, 2. So the radius is 2, and I'll sketch that in there. Just be careful, the scale on these, if you notice, this is one whole movement, and that's a second whole movement. I know you see those extra lines, so just kind of be aware of that. So then let's get going to our equation like it asked for, x minus 4 quantity squared plus, this is going to be y plus 1 quantity squared, and then 2 squared is 4. So here is my equation. All right, I'm going to jump right over here to 21. Here's the center of the circle. Here's the origin. So we went 1, 2, 3 to the left and up 1, 2, 3. So the center would have been left 3 and up 3. And in terms of the radius, 1, 2, 3 units. So the radius is equal to 3. So for my equation, I'm going to have x plus 3, looks like, quantity squared, plus y minus 3, quantity squared, and that's going to be equal to 9. So there is my equation of the circle. All right, we'll knock out the last 2 questions here. So the center for this is going to be located at 2, 2, and a radius of 2. And then don't be thrown off, all right? Look at the scale. This is going by 2s, 2, 4, 6. Let me scroll down. Let's look at letter B, also a scale of 2. Letter C, also a scale of 2. Letter D, scale of 2. So they're all scales of 2. So now when you think in terms of location of the center, that's what we've got to focus on, which is at 2, 2. So here's 2, 2, and it's not located there. Let me scroll down. Let's look at B. B is not located at 2, 2. C is not located at 2, 2 either. So it has to come down to D or E. This is located at 2, 2. This is also located at 2, 2. And then remember, our radius from up above was just a value of 2. So this has a radius of 2. This actually has a radius of 2, 4. That has a radius of 4. So it cannot be that one. And then that means that it has to be letter D. All right, let's look at 23. The center here is at -3, 0. And then the radius is going to be equal to the square root of 10. And if you think about it, the square root of 9 is 3. So the square root of 10 is going to be something that's really close to that. But I want to make sure I know where the center is. It's got to be at -3, 0. And notice the scale here, these are also going by 2s. So -3, 0. And there's only one that has a center at -3, 0, so that works. And then this should be a radius that's a little bit more than 3. 1, 2, 3. And it looks like it goes to me just a little bit beyond there. That line or the curve of the circle goes just past. So I would say that this is going to be our best choice. The other options did not have a center that was at the proper location, and then a radius that's really close to 3 and a little bit over. I would say that this accomplishes that. So that's why I would choose C over none of these. The center is correct, and that radius seems to be extremely close to what we were needing. All right, so this concludes the step-by-step walkthrough on the practice exam for the solutions. I highly recommend, if you have not done so yet, that you get on there and you take care of the topic 5 and the topic 6, Delta Math. It had to do with arc length and then the equations of circles. And if you have not done the quick check on topics 3 and 4, that's also posted on there. I would make sure that you get on there and you go back a week to the other post. Make sure you take care of that, because that stuff, if you didn't do it the week before spring break, is now assigned this week. So if you did it during the week before spring break, then you've really kind of been, moving a little easier here because you took care of business. If you haven't got that accomplished, make sure you get that done by Friday, because at Friday that's going to be the deadline to have that stuff done. So make sure you have that all taken care of. Remember, email me if you have any other questions. Hope you guys are all doing well.